Hello everyone, this is Tiger again, and today let's look at JMC 2016, and this is going to be the second half of this paper, which is questions 16 to 25, alright? So let's take a look at what kinds of questions we have today. And we will start with question number 16. So this one is going to be about some symmetry, alright? So I would say that it's a geometry question, definitely. And it's related to either you can say it's rotational symmetry or reflectional symmetry, all right? Because it's going to be about both of them. Yeah. So now you want to color the maximum number of squares such that it has rotational symmetry of order 2 but no lines of symmetry. Well, what does it mean by rotational symmetry of order 2? It means that when you flip the shape around, it's still going to look the same. All right? That's a characteristic of the rotational symmetry. So now we know that the center square can definitely be shaded because no matter how you turn it, the center square is still positioned in the center. And after that, we can classify the outside squares into 4 groups. Group 1, Group 2, Group 3, and Group 4. So when you color one of them, you have to color the other to have a rotational symmetry of order 2. However, if you are coloring 1 and 2 at the same time, definitely you can see that it's going to be a cross right there, right? So it's having some lines of symmetry. So let's say if you're coloring 3 and 4 at the same time, it's just going to be like a cross, which also has lines of symmetry. So what can I do? Essentially, I can just choose one of the 1 and 2s to shade and one of the 3 and 4s to shade. Such that after doing that, if you are shading in group 2, then there will be a line of symmetry like that. And if you're shading in group 4, of course, it's either going to be a horizontal or a vertical line of symmetry, which means that you cannot shade either 2 or 4. So the answer is going to be 5 boxes. That's all you can shade. All right. And the next question, question 17. So this one is going to be about ratio. So it is a word problem on ratios. So now, we have a group of 48 children and the ratio of boys to girls is 3 to 5. And it is asking you how many boys must join the group to make the ratio of boys to girls 5 to 3. So it means that only the number of boys is going to change in these two ratios, right? So the number of girls is actually the same, even though the number of parts are different. So we need to find the number of girls first. And that's equal to 48 times 5 parts out of 8, which is equal to 48 times 5/8, and that's going to be 30. So we know that there are 30 girls. And now we want to know how many boys must join the group, right? So you can either find the number of boys previously and after the change and find their difference, or the other way is that you can find the new total. How do we find the new total? We know that the girls is not going to change, right? And now the girls is 3 parts of the new total, which means that the new total is going to be 30 multiplying 5 adding 3 over 3. So 5 adding 3 is the total number of parts. 3 is the number of parts for girls. So we're going to have 80 as the new total. So now the number of boys joining is just the new total, take away the old total. because only boys is increasing, right? And that's 32. So we have the answer C, 32. And as for question 18, so this is a number puzzle question. So it belongs to the miscellany module, and it's going to be an addition puzzle. All right. So we have C adding C equals X's. Now, if two 3-digit numbers is going to add up to a 4-digit number, it means that the two S must be greater than or equal to 5 at least to have a carryover. Yeah? And also we can see that in these two columns, we both have two E's added up, but then the outcome is different. Right? Which means that when two E's are added up, there must be a carryover. Otherwise, the outcome should be the same. So, we know that E is also greater than or equal to 5. Now, let's think about the different possibilities of E. If E is less than 7 or equal to 7, S would be smaller than or equal to 14, right? The S would be smaller than, well, let's say 2E would be smaller than or equal to 14. But now, I need 2E to be 10 adding S, right? Which means that 2E has to be greater than 15 or equal to 15. So now I know it doesn't work. And if E is equal to 8, 2E is going to be 16, and then 2 8 is going to add up to 16 with an extra 1. That's going to be 17, which 7 is not equal to 8. So in the tens column, we can see that it doesn't fit, right? So finally, we have only one option left, which is when E is 9. So when E is 9, two 9s are going to add up to 18. So S is greater than 5. And two 9s adding up to 18, adding 1, that's 19. Right? So it fits. All of the E's are 9s now. And S is going to be 8. Two 8s added up, 16, adding the 1, carrying over. So it's 17. So the whole calculation is 899 adding 899, and that's 1798, which X is going to be 7. Okay, so we can just use the tens and the ones column to compare them to see which of these is going to be true. And that's how we can do it. All right. And then for question 19, it is a word problem on fractions. It says that there are 3 boxes which all contains the same number of fruits. The first one is having 12 apples and a 9th of all the pears, which means that in the other 2 boxes there will be 8/9 of the pears combined, which means that each of them is going to have 4/9 of the pears. And we know that all of them have the same number of fruits, which means that 12 apples adding a 9th of the pear is 4/9 of the pears. Well, in terms of the number, so it means that 12 adding a 9th of P is equal to 4/9 of P, where P is the number of pears. So we know that 12 is a third of P, and P is 36, which means that there are 36 pears altogether. And in each box, we have 4/9, which is going to be 4/9 times 36, and that's 16. So the answer is going to be B for this question, okay? All right, and then we are moving on to the next problem. So I'm just going to hide my hat for now because this is slightly a long one. I would say this question is actually just numbers and operations. And it's going to be defining new operations. So you might say, Tiger, you must be talking nonsense. This is definitely a geometry question, isn't it? With all those squares and stuff and area and stuff. Well, it's having a geometric background. However, have you learned anything about a cyclic quadrilateral before? I don't think so. I don't think so. So literally, it is just telling you the rules of how you can calculate it. And all you need to do is just to follow the rules. It tells you that the area is given by this formula. And S is half of the perimeter of this quadrilateral. So we can find S first. That's going to be 4 adding 5 adding 7 adding 10 divided by 2, which is going to be 26 divided by 2. That is 13 centimeters. So what is the area? We just need to replace A, B, C, and D by the 4 side lengths, 4, 5, 7, and 10. So that's going to be equal to the root of 13 take away 4, which is 9, times 13 take away, well, let's say this is 4, okay? 5, 7, 10, and all the adds are going to be 13. And then 13 take away 5, so 8. 13 take away 7, that's 6. 13 take away 10, that's 3. So we want to find the root of that. And what will be a simpler way to do it? Well, essentially you can just try to write all of these as their factorizations, as their prime factorizations. So 9 is 3 squared, 8 is 2 cubed, 6 is 2 times 3, 3 is 3. And that is going to be equal to the root of 3 to the power 4 times 2 to the power 4, which means that it's going to be 3 to the power 2 times 2 to the power 2, which is 36. That's 9 times 4, right? So the answer is going to be 36, which is E. Such that you don't need to complete the multiplication and then taking the square root of it. Well, that's just what you can do. All right. So that's just defining new operations, which means that you are just substituting these values into the equation. That's all you need to do. And then moving on to question 21. Moving on to question 21. Let's say this is going to be a geometric question. So it belongs to the geometry module, and it's going to be the area in grids. So first of all, we can see that we have a pentagon there by removing this triangle from the whole. Where this triangle, you can see that it's 1/8 of the whole square, right? And for the shaded triangle, the base is 3, the height is 6. So, well, it's going to be 1/4 of the square. So now the fraction of the area is just going to be the area shaded over the area of the pentagon, right? We know that the area of the pentagon is 7/8 and the shaded area is 1/4 of the whole square. So that's how we can express the fraction, which is going to be 1/4 multiplying, 1/4 divided by 7/8, which is multiplying 8/7. So that's 1, that's 2, which gives us 2/7. Of course, you can also try to find the area of each part of them, given that they're all on the grid. So you will be able to calculate each section of them and use the numbers exactly to find the fraction, which I have included in my solution as well, like the PDF version of it. So if you think that method is easier to understand, of course you can follow it. All right, so that's question 21. And as for question 22, it's another geometry question on splitting and regrouping. So it is not really about splitting, but it's more about regrouping. So we have 4 triangles like this joined together. Well, we know that when we are connecting 2 of these triangles, one of the sides of one of them is going to stick to the other side of the other, right? Which means that every time I combine 2 of them, I'm going to lose 2 sides. Which means that if I'm connecting all 4 of them, the first one to the second one, to the third one, to the fourth one, I'm going to lose 3 times 2, which is 6 sides in the perimeter. Because I need to make 3 connections, right? So I will have 6 sides lost. And to make the largest possible perimeter, I want the shortest sides to be lost. So I'm just picking 6 shortest sides out of all these 4 triangles. So of course I'm taking away 5 of them, like 4 of the 5s and 2 of the 12s. So altogether I have 5 adding 12 adding 13 times 4, that's 120. Take away 5 times 4, so that's 100. Take away 12 times 2, that's 76. All right, so the answer is 76. And how can we make them? We can just make them like that. So that's 2 5s lost, and that's 2 12s lost, and then finally 2 5s lost again, just like that. So we can make a long parallelogram. Okay, that's for question 22. And as for question 23, I need to hide my head again. So it is asking you to find the length of the 12th square following this pattern, where it forms a spiral sequence of squares. Okay, so the word sequence is pretty much important because that kind of hints us what to do. And I would say again, it does not belong to geometry. It belongs to numbers and operations, which it is a Fibonacci-like sequence. Fibonacci-like sequence. Okay, and why so? How so? So for the first 3 squares, their lengths are 1, right? And starting from the 4th one, it has got a length of 3. And for the 5th one, it is a length of 4. For the 6th one, it is having a length of 3 adding 4, that is 7, right? And for the 7th one, it's 7 adding 4, which is 11. And for the 8th one, it's 7 adding 11, which is 18. So you can see that each term in this sequence is the sum of the previous 2. 7 is 3 times 4, 11 is 4 times 7, 18 is 7 times 11, and so on. Which means that the 9th term is going to be 11 adding 18, that's 29. The 10th term is 18 adding 29, that's 47. The 11th term is 29 adding 47, that is 76. And the 12th term, it's 47 adding 76, that is 123. So the answer is B, 123. Okay, so that's what we can do with this one. And then for question number 24. So this one is slightly more interesting. It's a counting problem. And it belongs to the dying problems in counting. Because we are coloring these tiles with different colors, right? So it says that 3 different colors are available. And at least 2 of each color will there be, which means that you can feel free to use any colors, but tiles of all 3 colors must be used. So if you need to fill 3 colors into 4 tiles and all of them needs to be used, it means that one of the colors is going to be repeating, right? So first of all, we can break this question down into 2 steps. Which is, the first step is to choose which 2 tiles are of the same color. I don't know what color it is right now, but I'm just choosing 2 tiles to have the same color. And then we know that for 3 different colors, there will be 3 different sets among these 4 tiles, right? One of the sets is going to have 2 tiles. And the other 2 sets is going to have 1 tile and 1 tile, right? And for the 3 colors, I just need to assign them into these 3 sets. And the second step will be investigating how many ways can I assign these 3 colors to the 3 sets. Okay? So these are the 2 steps we can do. So first of all, we investigate how many different patterns of the same colors can we find. So if I'm naming these squares 1, 2, 3, 4, I can say that it's going to be either 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, or 3, 4, which is 6 different choices, right? Of 2 colors to be the same. And let's say now I have 1 and 2 the same, 3 different, and 4 different. Just an example. And now I'm assigning 3 colors there to the 3 groups, such that I can make different patterns, right? So it can either be green, purple, red, green, purple, blue, green, blue, purple, blue, purple, green, blue, green, purple, purple, blue, green, purple, green, blue. Yeah, so there are also 6 choices. Or if you want to do it the numeric way, well, the first one has 2 tiles. I mean, the first set of colors has 2 tiles, and then 1 tile, and then 1 tile, right? So the first set of colors to choose the color, the first set to choose the color is going to have 3 different possible colors to choose from, right? And whichever color goes to the 2 tiles, the next set is just going to have 2 colors remaining. And whatever the colors go to the first 2 sets, the last set would have no choice but to take the remaining one, right? So altogether, you just need to multiply these together because we are doing these choices step by step. And each step can vary in these numbers of different ways. So we have 36 as the final answer. All right, so that's going to be 36 for this one. This one might be a little bit challenging. It requires you to have a high level of mathematical logic in order to sort the priorities out or like to clarify the steps. And then for the last one, so the last one I would say is the hardest question of this paper. So it belongs to geometry. And again, as many hard questions are, it belongs to spatial recognition. Maybe a little bit about the odd-even analysis, because we can see that on a 5x5 board, there are 25 boxes, right? And each domino is 2 boxes. which means that the remaining is going to be equal to 25 take away a number of 2's. That is odd. Take away an even number. So it has to be an odd number. The remaining has to be an odd number, which means that 4, 6, and 8 are not possible. So now we just need to investigate 5 and 7 to see which one of them works. So probably I can draw a little bit of a 5 by 5 grid there. Oh, is that too much? 1, 2, 3, 4. Oh. Yeah, probably that's not the best drawing I can do. So 1, 2, 3, 4. 1, 2, 3, 4. Okay, so now I have a 5 by 5 grid. So in order for the first column to have the most number of squares left blank, what I can do is I just take the alternative boxes, right? I just leave the alternative boxes blank, such that I'm going to have 3 of them. But then horizontally, it also cannot last as long as 2 boxes. Otherwise, it will be able to have a domino filling it in, right? So I need to fill these gaps with some dominoes as well. And then the same goes for the next column. The same goes for the next column. I can't allow these openings to be filled by any other, I can't allow these holes to be filled by any other dominoes, which means that I don't want these 2 blanks to be filled. But if I did this, it means that all these horizontal rows, they can be filled by dominoes, right? Which is definitely not a clever choice for us. So what I can do alternatively is just to color it vertically, such that I can cover it up. Or of course you can also do that, which makes no difference. That is just leaving 1 blank in there, right? And then finally for the last one, you have to cover this up to avoid this blank going there. So the top, which means that you're leaving 1 blank in the last column as well. So altogether we have 1, 2, 3, 4, 5, 6, 7 blanks. And that's going to be the maximum. So the answer will be 7. The answer will be 7. Okay? And these are eliminated. So you just need to try between 5 and 7. Just try to make it 7 because that's the larger one, right? So try your best to make 7. If you can't, then the answer would be 5. But then since we can make the number of blanks 7. So that's going to be 7. Okay? So that's all we need to do for the last question right here, question 25. And that's it for this half of the paper. Okay? So thank you very much for listening today, and I will see you next time. Bye bye.